Hello everyone, welcome back to my Inspiring Logic Show. In today's video, we are going to learn about an important lean manufacturing technique called SMED. SMED means a single minute exchange of die. However, wondered how manufacturing company can reduce machine setup time and quickly change from producing one product to another product. So that is the my today topic. So I will explain in clearly. So let's start about this topic. Single minute exchange of die SMED in lean manufacturing. So SMED stands for single minute exchange of die. A lean manufacturing technique used to reduce the time required to change a machine from producing one product to producing another product. So in simple word, SMED means changing a machine from one product to another as quickly as possible. Ideally, it less than 10 minutes. Here single minutes does not mean exactly 1 minute. So it means that changeover time should be measured in single digit minutes, such as 3 minutes, 5 minutes, 7 minutes, 9 minutes. The main objective is to make machine changeover fast, simple, safe, and repeatable. So what is changeover? Before understanding SMAD, we need to understand the meaning of changeover. Before understanding SMED, we need to understand the meaning of changeover. A changeover happens when a machine or production line is changed from making one product to making another product. So one simple example, I will explain that. Imagine a machine produces product A to product A, then product A, then product A. Now the company receives an order from product B. The machine must be stopped and changed. So stop machine, remove old tools, clean, install new tools, adjust machine, test, start product B. So all the time spent doing this is called changeover time. So see that is the example. I will clearly explain that how to start first. So how to change from product A to product B. Stop the machine, remove the old tools, clean, install the new tools, adjust the machine, then test, start over product B. So all the time spent doing this is called changeover time. So in simple example of changeover, imagine a factory producing different sizes of metal parts. So at 8 a.m. a machine is producing small parts. At 10 a.m. the company needs to produce large parts. The machine must be stopped. Worker may need to stop the machine, remove the old die, bring the new die, install the new die, adjust the setting, check dimension, produce trial presses, then make correction, restart production. Suppose this takes 60 minutes. So during those 60 minutes, the machine is not producing normal output. Worker are spending time on changeover. Production capacity is lost. So SMED tries to reduce. So SMED in single minute exchange of die tries to reduce this 60 minutes to smoothing like 60 minutes, 30 minutes, 15 minutes to 9 minutes. So this is the basic idea of SMED. So what is a die? So what the word die in SMED comes from the manufacturing process such as pressing, stamping, forging, forming. A die is a tool used to shape. A die is a tool used to shape or form a material. For example, a metal stamping machine may use one die to produce a particular component. If the company want to produce a different component, the die may need to be changed. However, SMED is not limited only two dies. The same principle can be applied to CNC machine, injection mold machine, printing machine, packaging machine, welding equipment, food processing equipment, assembly lines, textile machine, pharmaceutical equipment. And so SMED is basically a changeover time reducing method. So why this made is important? Why this made is important? So this is the one more important topic. Why this made is important? So long changeover times create many problems. Suppose a machine takes 2 hours to change one product to another product. The company may think, so let's produce a very large quantity of product A so that we do not have to change the machine frequently. This creates large batches. For example, produce 10,000 units of a changeover machine and produce 10,000 units of B, but a customer may not need 10,000 units at once. So this can create excess inventory, long waiting times, higher storage cost, overproduction, reduced flexibility. If SMED reduces the changeover from 120 minutes to 10 minutes, the company can change products more frequently. So then it becomes possible to produce smaller batches. For example, A to B, B to C, C to A to B, B to C. This supports lean manufacturing. So this is the example. Then the main goal of the SMED, the main goal is reduce changeover time so that the machine can change from one product to another quickly and efficiently. This allows companies to produce smaller batches, reduce inventory, improve machine availability, increase flexibility, respond faster to customer, reduce waste, improve productivity. The basic of SMED, the basic of SMED concept. SMED mainly focus on separating changeover activity into two categories. First, internal activities. These activities can be performed only when the machine is stopped. External activities. These activity can be performed while the machine is still running. This distinction is extremely important. So internal setup. So that is the internal and external activities. Then one more new topic is internal setup. So internal setup. An internal setup is an activity that requires the machine to be stopped. An internal setup is an activity that requires the machine to be stopped. Example: removing a die from the machine, installing a new die, connecting certain machine component, performing adjustments that require machine stoppages. For example, suppose a stamping machine must stop before the old die can be removed, and removing the die is an internal activity. Then another topic is external setup. So an external setup is an activity that can be completed while the machine is still operating. An external setup is an activity that can be completed while the machine is still operating. Example: bringing the next die near the machine. So an external activity, an external setup is an activity that can be completed while the machine is still operating. Example: bring the next die near the machine, prepare tools, checking the new die, and cleaning the replacement die, preparing documents, setting up material, collecting required measuring instrument. For example, a worker needs a new die for the next product. Instead of waiting until the machine stops to find the die, the worker bring the die to the machine before changeover begins, and this reduce downtime. The most important SMED idea, the most important SMED principle is convert as many internal activity as possible into external activity. Let's understand with an example. So before SMED machine stop, Then the worker searching for the new die 5 minutes, bring the die 5 minutes, find the tool 5 minutes, remove old die 10 minutes, install new die 15 minutes, adjust machine 20 minutes. Total on an average 60 minutes. The problem is that some activity that could have been completed before the machine stopped were being performed during downtime. So after SMED, the company prepares everything before stopping the machine. The company prepares everything before stopping the machine. Before stoppages, new dia is ready. So before machine stoppages, the new dia is ready, tools are ready, materials are ready, measuring instrument are ready, setting are prepared. Now the machine stops only the activity that truly require stoppage. For example, remove old die 10 minutes, install new die 10 minutes, final adjustment 5 minutes, test 5 minutes. So total equal to 30 minutes. The further improvements can reduce it. So 30 minutes to 20 minutes, 20 minutes to 12 minutes, 12 minutes to 8 minutes. This is SMAD journey. So four basic steps of SMAD. SMAD is commonly explained through four major steps. Step one, observe the current changeover. Observe the current changeover. Observe the current changeover. First, carefully observe the entire changeover. Do not immediately try to improve it. So record what actually happens. For example, activity and time. Stop machine 1 minute. Search for tool 5 minutes. Bring new dia 5 minutes. Remove old dia 10 minutes. Clean machine 8 machine. Clean machine 8 minutes. Install new die 15 minutes. Adjust setting 20 minutes. Trial production 10 minutes. So total 74 minutes. The first objective is to understand where the time is being spent. The first objective is to understand where the time is being spent. So that is the most example. You can see it. Then step 2, separate internal and external activity. After observing the changeover, classify every activity. So bring a new die, external, prepare a tools, external, cleaning new die, external, remove old die, internal, remove old die, internal, install new die, internal, machine adjustment, internal, prepare inspection improvement, external. So now the company can see which activities are unnecessary being performed while the machine is stopped. So step 3, convert internal activity into external activity. This is one of the most important steps. Suppose worker spend 10 minutes finding and preparing tool after the machine stops. Ask why you prepare these tools before the machine stops. If yes, convert that activity from internal to external. Before machine stop, find out tools, prepare tools, and change die. Then after, prepare tools while the machine runs, machine stops, change dia. This can immediately reduce machine downtimes. This can you can improve it, then immediately reduce the machine downtimes. So simply and improve all activities. After separating internal and external activity, improve remaining activity. So use methods such as quick changeover, use methods as quickly clamps, use some methods as quick clamps, standardized tools, locating pin, and preset adjustment, visual marking, checklist, parallel war, standard war, better machine layout, elimination of unnecessary adjustment. The objective is to make the changeover. So fast plus simple plus safe plus repeatable. For example, CNC machine. Let's take a detailed example. A CNC machine produces two different components, component A and component B. So currently changing from A to B takes 15 minutes. So current process, finished product A. So current process, what will do? So current process finished product A, stop machine, search for tools, bring a new picture, remove old picture, install new picture, enter machine setting, adjust picture, produce trial pad, measure trial pad, make correction, start production. This will current process. In total, on and average, 50 minutes. So this will change it required. So after that, applying SMED to the CNC machine, applying SMED to the CNC machine. Step 1, prepare everything before stopping. The worker prepares new picture, tools, and measuring instrument, program, raw materials. While the machine is still producing product A, this converts several internal activity into external activities. Step 2. Use quick clamps. Instead of using several bolts that takes 10 minutes to remove the titan, the company has quick release clamp tool there. So time 10 minutes to 2 minutes. Then step 3. Use locating pin. Locating pin helps position the picture correctly. This reduces adjustment time. And step 4. Use preset setting. Use preset settings. So machine settings are prepared in advance. Instead of adjusting everything manually after installing, the operator uses predetermined setting. Step 5. Perform activity in parallel. So one worker changes the picture while another prepare the inspection equipment. So instead of worker A finish, worker B starts, and they work simultaneously. For CNC example result. So before SMED 15 minutes. After improvement activity, find tools 5 minutes, then to 0 minutes, bring picture 5 minutes to 0 minutes, remove picture 8 minutes to 3 minutes, install picture 10 minutes to 4 minutes, adjustment 12 minutes to 5 minutes, trial and inspection 10 minutes to 4 minutes. The total changeover can be reduced dramatically. For example, 15 minutes to 16 minutes, while further improvement 16 minutes to 9 minutes. And the riches of the traditional meds targets of a single digit minutes changeovers. Another example, injection molding. So imagine a plastic factory producing bottle caps. The machine currently produces product A. Now it needs to produce product B. So the mold must be changed. Old method the machine stops. And then workers search for mold, bring mold, clean mold, find tools, remove old mold, install new mold, connect pipes, adjust setting, produce test pieces. So changeover time equal to on an average 90 minutes. So applying SMED to injection molding. Before the machine stop, new mold is inspected, mold is clean, tool are prepared, material is prepared, machine setting are required process and connection are prepared. Then the machine stops. So worker remove old mold, install new mold, connect required equipment, and use preset setting. Perform a quick quality check. Suppose the changeover becomes 90 minutes to 35 minutes after additional improvement. After additional improvement, 35 minutes to 15 minutes, eventually 15 minutes to 8 minutes. Now the company can changes from mold much more frequently. So SMED example in bakery. SMED is not limited to heavy manufacturing. Imagine a bakery has a machine that produces different sizes of bread, changeover from small bread to large bread. So take 40 minutes. Worker needs to clean equipment, change setting, replace guide, prepare ingredients, adjust machine. So using SMED. So before the machine stop, prepare ingredients. Before bring tools, prepare guides, record machine setting. During the stoppage, replace guides, change necessary component, adjust machine, test production. Changeover 40 minutes to 15 minutes. This allows the bakery to produce different products more frequently. SMED example in packaging. Imagine a company 500 ml bottles and then needs to package 1 liter bottles. The packing machine needs to be adjusted. The whole changeover takes 45 minutes. The worker spend time finding parts, adjust guide, changing label, setting machine parameter, and testing bottles. Using SMED, the next products, component and tools are prepared before the machine stops. So quick adjustment mechanism are introduced. Standard setting are marked. Changeover becomes 45 minutes to 12 minutes. And the company can switch between bottle sizes more easily. Then SMED and small batch production. Small batch production. So one of the biggest benefit of SMED is that makes small batch production more practical. Suppose a company has a machine that takes 2 hours to change. The company may decide we should produce 5,000 units at once so that we do not have to change the machine frequently. This creates excessive inventory. Now suppose SMED reduces changeover time 10 minutes. The company can produce 500 units, change 500 units, change 500 units. This makes production much more flexible. Why small batches matter? Small batches can provide several benefits: lower inventory, faster response to customer, less production, shorter lead time, earlier detection of quality problems, greater production flexibility. Therefore, SMED to faster changeover to smaller batches, lower inventory, better flow. This is an important relationship. SMED and inventory. So long changeover times often encourage companies to produce large batches. So large batches create inventory. SMED reduces changeover time. Therefore, company can reduce batches. Relationship. So long changeover to large batches, long changeover to large batches, high inventory to more storage, more relationship. Long changeover to large batches to high inventory to more storage to more waste with SMED. Short changeover to smaller batches to lower inventory to better flow to less waste. SMED technique. SMED technique. So several techniques can be used to reduce changeover time. So first one is quick release clamp. So replace bolt and screw with quick clamps where the appropriate. For example, instead of spending 5 minutes tightening multiple bolts, quick clamp, lock and down. So second one is standardization. So use standardize tool, fixture, setting, procedure, component. Standardization makes the process easier and faster. Third one is pre-setting. So prepare machine setting before the changeover. Instead of adjusting everything after the machine stop, the operator uses predetermined value. Locating pins. Locating pins helps component or fixture fit into correct position quickly, and this reduces adjustment time. Then visual marking. Visual marking. Use color coding. The visual marking. Use color coding. Levels, lines, number, visual indicator. Example, a red mark shows the correct position of a machine guide. The operator does not need to spend time guessing the correct position. Parallel operation. Two or more people perform different changeover tasks simultaneously. Sequential method worker A to worker B, B to C. Parallel method worker A to B, worker A plus B plus C. So this can significantly reduce total changeover time. Checklist. A checklist ensures that tools, metrics, settings, and components are ready before a machine stop. Then 5 Bs. A clean and organized workplace helps worker finds. So tools, materials, fixture, measuring instrument, and quickly 5 Bs therefore the support SMED. Then SMED and 5 Bs. So 5 Bs and SMED work well together. The 5 Bs are commonly explained as sort, set in order, sign, standardize, sustain. Imagine a worker needs a particular range during changeover. During changeover. If the worker is disorganized, then search, find a range. This waste time is a waste time. So with 5 Bs, go to the marked location, pick the range, use it. The changeover become faster. SMED and standard work. One the best changeover method is identified. It should be standardized. For example, standard changeover procedure: prepare a new picture, prepare tools, confirm machine setting, finish current batches, stop machine, remove old picture, install new picture, apply preset setting, perform safety check, produce trial pieces, verify quality, start production. So every operator should follow the same basic procedure, and this makes the procedure consistent, predictable, easier to train, easier to improve. Then speed and quality. And speed alone is not enough. A changeover should be fast plus correct plus safe. Suppose a conveyor reduces changeover time from 60 minutes to 5 minutes, but produces defective products after that. So this is not a successful improvement. Therefore, SMED should reduce time without significant quality or safety. A good SMED system includes correct setting, quality check, standard procedure, error preventing, and proper adjustment installation. SMED and safety. Safety must be always come before speed. So workers should never bypass safety procedure just to reduce changeover time. For example, if a machine must be isolated before changing a component, the correct safety procedure must be followed. SMED should improve the process by removing unnecessary work, preparing tool workbench, improves accessibility, use appropriate fixture, reduce acquired movement. It should never encourage unsafe shortcuts. Benefits of SMED. So reduce changeover time. This is a main objective. So benefits of SMED: reduce changeover time. This is the main objective. Smaller batch sizes. Companies can change products more frequently, lower inventory, and smaller batches reduce work in progress and finished good inventory. Higher machine availability. Machine spend more time producing. Machine spend more time producing. Greater flexibility. Company can respond more easily to changing customer requirements. So reduce lead time. Products can move through the production system faster. Reduce waste. Less waiting, inventory, motion, and overproduction. So better productivity. More production time is available. Improve customer service. Customer can receive different products more quickly. Better workplace organization. SMED often encourage standardize and prevention. The disadvantages or challenges of SMED. SMED has many benefits, but implementing it can be challenging. Initial investment. The company may need quick clamps, fixture, tools, equipment modification. Employee training. Worker need to understand the new process. Resistance to change. So employee may initially prefer the old method. So machine limitation. Some machines are difficult to modify. Some machines are difficult to modify. And supplier or product variation. Different product may require different setups. So safety consideration. Change must be implemented without compromising safety. Continuous improvement is required. Achieving a shorter changeover once it is enough. The process must be maintained and improved. Important of the SMED measurement. A company should measure it changeover performance. So important measurement include changeover time, the time required to change from one product to another product, setup time, the time spent preparing for the machine from the changeover time, the time required from the one product to another product, setup time, the time spent preparing the machine from for the next production runs, from machining at the finish of the product to the next production of the run. So fast food part time. So how long it takes to produce the fast acceptable quality product after changeover, fast food part time, downtime. The time during which is the machine is unable for normal production. So machine availability. The percentage of a plant production time that the machine is available. How to calculate changeover time. Suppose production ends at 10 a.m. Product B suppose product A production end at 10 a.m. Product B produces it fast food part at 10 to 25 a.m. and the changeover time is 25 minutes. So if SMED improvement, reduce this to 8 minutes. Old changeover 25 minutes, new changeover 8 minutes. The time saved 8 minus 25 minus 8, 17 minutes. That the 17 minutes can potentially be used for the productive manufacturing. Then a complete before and after example. So let's take a simple manufacturing example. A factory produces metal brackets. Before SMED, changeover time 60 minutes. Worker performs. So find tools 8 minutes, bring new die 7 minutes, remove old die 10 minutes, clean machine 8 minutes, install new die 12 minutes, other setting 10 minutes, trial production 5 minutes, total 60 minutes. Then SMED improvement before machine stops, prepare tools, bring die, clean replacement die, prepare material, record setting. Uses quick clamp, locating pin, standard setting, visual marking, parallel work. So after SMED activity or a new time. So removed old die 5 minutes, install new die 4 minutes, adjust setting 3 minutes, trial production 2 minutes, and total 14 minutes. So 16 minutes to 14 minutes. With additional improvement 14 minutes to 9 minutes. Now the changeover reaches the traditional SMED trial rate. The SMED improvement cycle. So SMED can be remember as observe, watch the current changeover, then record, measure every activity, separate, identify internal and external activity, convert, move internal activity to external wherever is possible, simplify, make remaining activity faster and easier, standardize, create a standard changeover method, improve, continue reduce the time. SMED in simple diagram. SMED in simple diagram. Current changeover, observe the process, observe with current changeover, observe the process and record every activity. So internal activity, external activity, machine stopped, machine running. So machine stopped, convert the external convert to external where possible. External activity, machine running time, prepare in advance. So both are simplify the remaining changeover activity, standardize the work, reduce changeover time, smaller batches plus less inventory plus better flow. Difference between SMED and GIT. SMED and GIT are closely related, but they are not the same. So SMED and GIT are closely related, but they are not the same. SMED so focus on reducing changeover time. GIT focus on producing or supplying when needed. So makes machine changeover faster, reduce unnecessary improvement and production. SMED, focus on reducing changeover time, focus on producing or supplying when needed, makes machine changeover faster, reduce unnecessary inventory and production, support smaller batches, support demand-driven production, use quick change technique, use pull system and synchronized flow. Example, change die in 8 minutes. Example, receiving material when products needed. Relationship: SMED, faster changeover, smaller batches, lower inventory, support JIT. So SMED is one of the technique that can help many achieve lean and JIT objective. The difference between SMED and Kaizen. The difference between SMED and Kaizen. SMED specially focus on reducing changeover or setup time. Kaizen focus on continuous improvement of process. Continuous improvement of process. SMED can actually be considered a focus improvement approach that uses the broader lean idea of continuous improvement. A very small, simple real life example. A very simple real life example. Imagine you have a printer. Imagine you have a printer. You have printer. 100 pages in black and white. So a very simple real life example. Imagine you have a printer. You are printing 100 pages in black and white. Then you need to print 100 pages in color. Suppose changing the printer setting takes 10 minutes. You can improve the process by preparing the color setting beforehand. Instead of finishing black and white, searching setting and change setting, test, print. You can prepare color setting ready, finish black and white, change setting and quick test and print. So you can reduce the changeover time. This is the basic thinking behind SMED. Key points to remember. Suppose if you need to remember SMED for an exam, remember this point. SMED means single minute exchange of die. Main purpose reduce changeover time. Main concept separate internal and external activities. Important improvement convert internal activity into external activity. Common technique, quick clamps, standardization, present setting, locating pins, visual control, checklist, parallel operation, 5 Ps. The main benefits: smaller batches, lower inventory, less waste, higher flexibility, and a better machine utilization, faster production, shorter lead time. Targets: single and digit minute changeover. So, short example answer: what is SMED? So, short in example, SMED stands for single minute exchange of die. It is the lean manufacturing technique used to reduce the time required to change a machine from producing one product to another. The main principle of SMED is to separate changeover activity into internal activity, which requires the machine to be stopped, and external activity which can be performed while the machine is running. The goal is to convert a many internal activity as possible to external activity and simplify the remaining activity. SMED helps to companies reduce the changeover time, reduce smaller batches and lower inventory, improve machine utilization, reduce waste, and respond more quickly to customer demand. So this is called as the SMED. You can read and understand this. So then this is the structure. So this is the final definition. The easiest way to understand SMED. SMED is the lean manufacturing method for making machine changeover as fast as possible by preparing work in advance, separating internal and external activity, and simplify remaining the setup. Remember this formula: observe, separate, convert, simplify, standardize, and improve. And remember the main result: faster changeover, smaller batches, less inventory, less waste, better lean manufacturing. In conclusion, SMED is the important lean manufacturing technique because long machine changeover force company to produce large batches, which can create excess inventory and other form of waste. By reducing changeover time, company can change products more frequently and produce closer to actual customer demand. The central idea is very simple. Prepare before the machine stop, minimize the work that must happen while it is stuck, and makes every remaining steps quickly, simple, and standardized. This is the heart of single minute of exchange value. Hello दोस्तों, and this is my part 2 video in SMED. So I will explain that in that part 2 video in ACMA purpose, that is very important. So in part 2 video that I will explain it clearly. So let's start about this in my part 2 video in PDF wise. I will explain that. So SMED, see that image in carefully. So training on SMED, single minute exchange of die, single minute exchange of die. So lean manufacturing was born and raised in Japan. So it is based on the USA stratification of William Edward, and the principle was originally named as a Toyota production system. The American auto is had been adopted the system in order to survive, and see that is the image. And defining lean, a systematic approach to identify and eliminating waste and non-value-added activity through continuous improvement by following the product at the pool of the customer in pursuit of perfection. So there are lean manufacturing, so many tools are there in lean manufacturing. In previous video I will explain in that all these things. In this video I will explain that single minute exchange of die or SMAT. So single minute exchange of die. So fast changing customer demand. So fast changing customer demand. Quantity on right time, just in time in the delivery. Zero defects quality. Direct supply to customer line. Quick response to customer changing requirement. Continuous price reduction. And penalty for late delivery or poor quality supply. Value engineering projects and sharing the benefits with the customer. Participation in customer product development program. So meeting customer demands through flexibility in production, operating small batches, produce what customer wants only when he wants, bottleneck mitigation, single piece flow, and maximize use bottleneck customer, cost minimization, improve OE. This can be achieved by implementing single minute exchange of die. And single minute exchange of die. So single minute exchange of die SMED refers to therefore the technique for performing setup operation in not 10 minutes. The number of minutes explained in a single digit. The process was developed by Siango Sino and Majal. The most related the Toyota 1950 and 1960s. See that is the Sino Singo, and he is the industrial. All these things he is developed, and he is very intelligent person. So total lead time concept. Total lead time. See that image, and what is the setup time? What is the changeover time? And total non-value added activity. What is runtime? Time? We will explain that. So definition of the setup. The time interval between the completion of the last good part, the time interval, so the time interval between the completion of last good part of previous setup to the completion of the first good part in next setup. That is the setup time. So again, the time interval between the completion of the last good part of previous setup, last good part of the previous setup to the completion of the first good part of the next setup. So this is the setup time. Completion of the last good part, replace old die, locate tools or dies or pixel, attach new, runtime, enter offset, run part, adjust, completion of the parts good, one piece, one piece fast inspection. So setup time includes runtime, adjustment time, inspection time until a good part of this new setup is produced. Steps in setup procedure. So the preparation of machine after process adjustment, checking of material, tool, etc. mounting and removing blade, tool, parts, etc., measurements, setting and calibration, trial run and adjustment, trial runs and adjustment. So needs for quick changeovers, old practice, batch processing, batch processing setup time was fixed, lot size were variable, lower part unit cost by increasing lot size, economic order quantity formula, economic order quantity EOQ. So 2 into D into capital S divided by S root over, where D is the demand, S is the setup cost, H is the holding cost. So EOQ has setting high setup cost, low setup cost, idea case. So identify the setup problems. Identifying the setup problems. By using a percentage loading chart, you can quickly identify area to apply setup reduction technique. This is the setup reduction technique. And typical causes of the setup days. Typical causes of the setup delay. Searching, walking, waiting, no proper tool, no standard operating procedure for setup activity, poor schedule information, lack of teamwork. Setup goals. In 1992, world class startups, single minute exchange of time, so single digit minute 0 to 9. So 1919, world class startup one task exchange of die, so 100 seconds or less, 100 seconds or less. So before SMED, after SMED, see that image, you can clearly understand about this all over this topic. So typical changeover 5 to 10 minutes, typical changeover 5 to 10 seconds. So SMED methodology. Preliminary stage, observe and analyze in details how the setup is currently performed. Stage 1, separating internal and external setup activities. Stage 2, converting internal and external setup activities. Stage 3, streaming all aspects of the setup operation. Then SMED methodology. So see, then this is the same thing. Preliminary stage, observe and analyze in details how the setup is currently performed. Stage 1, separating internal and external set activity. Stage 2, converting internal and external set activity. Stage 3, streaming all aspects of the setup operation. Then observation and analyze of the current setup. So perform continuous work analysis with a stopwatch, study actual shop floor condition by interviewing worker, take video all activities, identify any unnecessary tasks through observation of video and eliminate, identify opportunity for small improvement, identify internal or external activities, identify value adding or non-value adding activity, identify normal and abnormal activity, identify and measure working time and waiting time, and solicit idea for countermeasures and improvements. So observation and analysis of the current setup. So example SMAD activity, and see that is the you can make that one. So that is the setup, so you can make that one. So what is the online, what is the offline? So it's online correct carried out when the machine is started is internal. Offline activity carried out when the machine is started is external. SMED methodology. So preliminary stage, SMED methodology. Preliminary stage, observe and analyze in details how the setup is currently performed. Stage 1, separating internal and external. Stage 2, converting and internal and external setup activity. Stage 3, streaming all aspects in the observation. So separate internal and external setup activities. So internal time is the time when the setup activities are performed while the machine is shut down. So my mounting and removing of die. So that is the internal activity. External time is the time when the when setup activity are performed while the equipment is running. So example, transporting old die to storage or conveying new die to the machine. So transporting old dies to the storage or conveying new dies to the machine. Separate internal or external setup activity. Separate internal or external setup activity by using a checklist, performing functional check, improve transportation of die and other parts. SMED methodology. So, say preliminary stage. Observe and analyze in details how to set up environment. Then PGL or I before time I explain. Then so converting internal or external setup activity. Converting internal or external setup activity. Preparing operation condition in advance. Elimination of search time, searching for picture, tools, gauge, hardware, etc. Elimination of work time, knowing where the tools are. Elimination of waiting time, waiting for host, pallet, container, carts, or trucks. Elimination of setting time, setting for picture, tools, or gauges. Elimination of waiting time, preheating of die, automatic program preset, function standardization. Standardization the operation, standard operating procedure, SOP, program preset, die brackets, jigs and picture. So converting internal to external setup. See that is the example. Elimination of source time using tools copyboard in shop floor. Then converting internal to external setup. Example, elimination of source time by visual indicator. Then converting internal to external setup or elimination of source time using picture standard. Then converting internal to external setup, for example, standardizing operation by program preset. Standardizing operation by program preset. Converting to internal to external setup, for example, standard operation procedure, SOP. So converting internal to external setup, example, standardizing operation using brackets for loading jigs. Then SMED methodology. So that is also same thing. So internal to external activity to stream all the aspects, etc. Then streamline the setup operation. Streamlining the setup operation. Where ideally improve in external setup operation. So improve in the storage, implement point of view storage POVs, improvement in transportation of parts and tools, automated conveyor to transport die. Radial improvement in internal setup operation, implementation of parallel operation, using of functional clamps, slot and fixture and T-bolts reduce attachment time, swing hook eliminates the need to remove knot from bolt, elimination of adjustment, fixing tool drop location in crates, using the functional clamp, see that image how to using the functional clamp, direct attachment method and bolt. Then one turn attachment. The following are the example of functional clamp that can fasten or unfasten object only you can turn. Then the pure shape hole method. The pure shape hole method. Fasten here attachment and remove here the plate. Pierce and holes method. So that is the U-shaped washer method. U-shaped washer method. The U-shaped washer method. The U-shaped washer method. The U-slot method. That is the U-slot method. U-slot method. See that you can clearly understand. The clamp method. See that image. That is the clamp method. And then that is the split thread method. Split thread method. And reduce no screw. Pushing cap. Reduce no screw. Wing nut method. Cap method. Wing nut method. So snap method or restraining work. Magnets. Contact with workpiece. Toggle clamp. So can apply pressing over 500 kg toggle cap and taper type U slot collar. Taper type U slot puller, gear slippage prevention, gear slippage prevention. So using gearbox power, so one touch slipper. So streamlining of the setup operation, example point of use storage, point of use storage. Streamlining setup operation, example use automatic functional clamp, use automatic functional clamp. Streamlining of the setup operation, use functional clamp, using functional to change adapter. So elimination of trial run and adjustment. Elimination of trial run and adjustment. Standardized setup, standardized fixturing, standardized tooling, guide book, templates, alignment bar. Then example are eliminating and adjusting by fixing tool drops located in cranes. Eliminating and adjusting by fixing tool drops located in cranes. So SMED methodology, that is the all and overall in the SMED method. See that image, you can clearly understand about the SMED methodology, which stages, stages 1, stages 2, stages 3, how the materials is running. So that you can understand. Then guidelines for quick setup change. So do not use cane for the loading and unloading the die. It takes time. Instead of doubling the slide and die. Standardize height and width of the die block to avoid current daylight adjustment save time. All member of the cell to be used in the changeover instead of one operator. They must be available near to the machine at the start. Changeover activity to start only when the required tools are ready. Close the machine. Inspection for a valid person to be available near to the machine of the check and measure the fast piece and fast changeover is completed. Guidelines for the quick and setup changes. Quick and setup changes. So quick changeover activities should start immediately after the last piece or previous setup is produced. Operators should lead the quick changeover activities. There should be a clear SOP and working instruction for SMED and displayed near the machine. All should strictly adhere to SOP. SOP and WI to be revised periodically as and when internal or external activities are streamlined for improvement or reduction of changeover. All operator must undergo training on SMED and their role is clear before start setup change. Case study. So SMED case studies are the before SMED and 16 minutes 30 seconds, after SMED 34 seconds. So that is the case study. You can read and understand about this case study, and one by one he will explain that in details. Then one more case study, before SMED, after SMED, how to implement that case study. Then one more case study, before SMED and after SMED, how to improvement. You can see that image. And the another case, before improvement, after improvement, using SMED for aluminum die casting die. So overviewing of the improvement in Prostago, eliminating of the individual pull and hose connection, elimination of preheating in internal setup, elimination of die closing adjustment, reduction of the number of the clamps for 16 to 8 by attaching a die cradle. 4 clamps were set at the fixed section and 4 of the movable section. So methods for combining die. So to move the die, we decided the use host and roller conveyor in the combination by simplifying tightening the connection slips by providing die cradles, and we decided preheat in the external setup. Example of a die changing method. Example of a die changing method, that is how to change in the die changing. He will explain that. And this die standardization, how to standardize this die, and he will mention that. And die positioning and centering, like positioning and centering. So see that image, that is positioning and centering. And that is the die insertion rack or die casting machine. Relationship between these two. See that image. And a die movement horizontal feed. Die movement horizontal feed. Die movements. Die movements. Locating ring engagement. Locating ring engagement. So see that image. Locating ring engagement. and improvement of the fixture, engagement of the fixed die sleeve or plunger sleeve, die sleeve or plunger sleeve, an improvement method of the connecting slipper blade and cylinder, and improve coolant, die preheating, use of internal spraying device. So that is a full image, and this is the full image. This is a thank you for this is my part 2 video. So I will explain that in my part 3 video. So that will help to understand in single minute exchange of time. So just like I am scrolling the SMED, just you can see an example in a PDF file. What is SMED in a simple basic. So we can read and understand definition of the changeover time. The time between the last piece of the current run and the first piece of the next run. That is the single minute exchange of time. So traditional changeover, this will and uh, and now the best changeover is no changeover. So the traditional chamber changeover and waste of lead, that is to make one file so that you can clearly understand. So that is the changeover improvement process. Traditional changeover. This is the traditional changeover in 2 hours in single part. So how to make that is the weekly core time 10 hours and around time 30 hours, average available time 0 hours. So that will take it. And 3 minutes is a changeover time. But 3 minutes changeover, so that will save example 4 times 75 minutes, round time 30 hours, available time 8.7 hours. What does quick changeover involve? Planning. What does quick changeover involve? Planning, practice, innovation, standardization, continuous improvement. And the impact of the quick changeover. See that is the impact, key benefits and impact of the quick changeover. Document of the current changeover. That is the document of the current changeover. How to do improve. A systematic approach is needed for single minute exchange of dye. So that will tell. SMED approach. Identify internal and external changeover tasks. Analyze each task's real purpose and function. Focus on a local solution. Aim is to eliminate changeover time. And the stages of SMED. So separate internal and external setup. Convert internal setup to external setup. Streamline internal and external setup reduction. Separate internal and external setup. So see that image, you can separate the internal and external setup. So then separate the internal and external setup. Develop and implement changeover checklist. Develop specific checklists for every piece of the equipment and measure process. What is needed, where it is needed, who needs to do what, how long should I take, where are the proper operating conditions. What are the correct setting for the next operation? Keep the checklist up to date and visible to all. Use checklist consistently prior to. Separate internal external setup. So perform function checks on parts or tools. All are the changeover materials in good working order. Tool, parts, picture. Have all materials been checked for enough to advance allow for the repairs? Then separate to internal and external setup. Reduce transportation of tools, parts and materials. Reduce non-value movement. Reduce non-value movement. Reduce non-value movement of the changeover parts, tool or material. Transport changeover materials before the machine shut down. Focus on and have low-cost solution. So no low-cost solution, reduce transportation. No or low-cost solution, reduce transportation. Then SMED convert internal to external setup. That is the setup. So we can see and the SMED convert to internal to external setup. That is a one by one. You will explain that. Then same thing, convert internal to external setup. So then you will make like that. Streamline internal or external elements. Streamline internal elements. Streamline internal elements. What is the? You can read that how to do it. So streamline internal elements. Be like that. See that these internal elements. So local selling position in pin and setup reduction tool, cat relay, standard wire, quick release, offline setups, water spider, setup documentation, improve machine reliability, and one-turn methods. The Titan here, attach remove here. The Titan here, attach remove here. That is also very important. The no close solution, one-turn method. Then wing node method. That is called wing node method. Wing node method. And it will streamline the element, use the functional term, one-turn method, no one motion method, interlocking method. This is the CAM method, and the streamline internal, that is the functional. So SMED is the streamline external elements, streamline SMED, streamline external elements. So three stages of SMED. But again, we per time we still explain that analyze analyze the SMED and applying SMED to complete set of assemblies that develop a novel solution, streamline and create and improve changeover process. Implement stage, implement, standardize, benefits of quick changeover, benefits of the quick changeover. So this is my part for video, and this one also one type of SMED. See that image, I will PDF, I will just showing like that. So you can clearly understand about it, the objective of this pad, and the definition of the setup is okay or not. So see that is and this is the definition of the internal or external operation. So internal can only carried out when the machine or process has stopped. External could be done while the machine or processing is running. Key to remember, set up our roadblock and we want to eliminate order and establish the priorities. So it depends on lot size or frequency setups. So I typically to set up so searching, so bring together, set of tricks, searching, bring together, and that is an improve to setup, and prepare tools add up the time, prepare tools add up the time, resembles, resembles machine as predicted and next kit, and internal to external convert as much as internal as soon as possible to external. So further improve to setups, and that one is the standardize, how to standardize one by one. You will explain and write it, and reduce, you can develop and don't use adjustable tool, and peer share ball, quick bold release, C clamp for the quick release, animation bold length, see, and that one also ideal setup, that one also one ideal setup, and the three tricks of the setup, and three tricks of the setups, eliminate combination setup, efficiency, TP, total productive effectiveness, evaluate rate, performance rate, and quality rate, how to calculate, and total productive effectiveness. I will explain that TP is 50%, then 100%, 86%, 50%, or 50%. Total productive effectiveness. And observation and analyze method. Observe the video. Is there no one on the screen provided four stages of the setup reduction. Four stages of the setup reduction. Stage 1, stage 2, stage 3, stage 4. And we will explain that in clearly. And analyze of the each steps and the graph wise. Analyze steps in the graph wise one by one in details. Analyze the step 3 in the graph wise. Then this one also same thing one by one. You will explain that. Then setup checklist. Can tool be changed in less than 10 minutes? Setup checklist. You can make these type of things. And SMED implementation. The agenda of the introduction about this both video. So in SMED, so we'll change in nature in production. Changeover, impact of change over time on production time. So impact on change over time and operation time. So economic large size with the traditional changeover. Problems in setup operation. Waste time. Birth of SMED, single minute exchange of die. And the birth of this SMED. The birth of this SMED. Why SMED is required. Why SMED is required. Why SMED is required. See that is, you will explain that in that image. So batch production option with quick changeover, traditional set of practices, traditional set of steps, then a traditional distribution on time, so traditional set of resource consumption and other analysis, and the pages, SMED roadmaps, the procedure for setup reduction, procedure for setup reduction, analyzing changeover using a video, analyzing changeover using a video, analyzing changeover using a video, break the changeover into elements, and you can break it, and separation of internal or external setup, procedure for ECRS analysis, procedure for action plan, and results from goal and action, results from the goal and action. So ops or change, setup, cleanup, setup, startup, and so the 7 stages of improving changeover. Step 1, changeover begins and ends with 5 years. Step 2, change internal changeover to external changeover. Step 3, bolts are our enemies. Bolts is our enemies. Direct attachment method and bolts. Pear-shaped bolts for clamping. U-shaped washer clamps for thin screw improvement. Step 4, if you have to use your hand, make sure you fit. Step 2, procedure for setup reduction, paper and adapter, 40% less working. Step 5, don't rely on special fine tuning skill. So the standard are standard, they are not flexible. Standard height of die and attachment edge. Improve setting of die on a fixed bolster. Standardize all changeover operation. So changing internal core to external core. Changing external core to internal core to external core. So improvement matrix, apply new method, send the change to others after necessary approval, put the new method to use right away, credit score, Changeover, continue to improve the new method, toolkit for setup reduction. So thank you for all watch this video. I will happy you watch this video, and please suppose you interested about this topic, so please like, share and subscribe this channel. So thank you so much.